Good evening, everyone. Yes. Good evening, everyone. Welcome to all of you for the third live interaction session for the course MATLAB-based programming lab in chemical engineering. So, those students who are new or who are joining for the first time, I will give my short introduction. I am Prasil Kapade. I have completed my BTech from SVNIT Surat in 2019. After that, I have worked in Reliance Industries Limited at Jamnagar for around a year, and there I used mostly S Pen. After that, I completed my master's from IIT Kharagpur, and there I learned this not the exact course but similar course from Professor Parag, and I'm going to have live sessions for this course only. And currently, I'm pursuing my PhD from IIT Bombay. So this is my personal web page and this is my LinkedIn page. If you have any queries, you can contact me. And this is the YouTube channel where you can get all the live interaction sessions. Videos will be uploaded there. So let's start today's session. So for today's session, I will switch off my camera first. Okay. So for today's session, we will be seeing various kinds of equations. I guess screen is visible. Yes. Uh, and Teams recording is also on. Just a minute. Yes. Recording is also on. Okay. So today we will be seeing first various kinds of equation. So first, what is called a linear equation? So we all know and we have learned these things. Linear equations are in form of, let's say, f of x is equal to ax plus b, where power of x is 1 or power of variable x is 1 and there is no other power than x. So this is called a linear equation. Now, other than linear equations, there are various types of nonlinear equations. Let's say ax square plus bx plus c is equal to 0. This is called nonlinear equation. I will just write L and NL. This is called nonlinear algebraic equation. So this is of x square type. We can also have, let's say, 2x cube plus 5x square plus 3x plus 1 is equal to 0. This is also kind of nonlinear equation. Let's say we are having equation in terms of 2 raised to x minus 3 is equal to 0. So this is also called a nonlinear equation. So let's take one more example. It is, let's say, x into e raised to x minus 5 times sine x is equal to 0. So this is also nonlinear equation. The difference is this kind of nonlinear equations are called algebraic or polynomial kind of nonlinear equation. And this kind of equation where e raised to x sine x, one more example we can take as e raised to 3x minus x by 2 plus 5 is equal to 0. This is also called nonlinear equation. So these type of equations are called transcendental equation. So the question is how to solve this kind of equation. So this is what we are going to learn in today's session. So sorry. Yes. So this is what we are going to learn in today's session. So let's say I am having this equation ax square plus bx plus c is equal to 0. So this is this called quadratic equation. So this we can solve by x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So using this, we can find direct solution of equations where it is the power is x raised to 2. But all time we won't get the power as x raised to 2. So these kind of equation, these nonlinear equations, how to solve it. So let's say I'm taking this equation 2x cube plus, I'm just taking one random example, 5x square plus 3x plus 1 is equal to 0. I am calling it as f of x, right? Let's say I am taking x is equal to minus 1. So my f of x will be 2 into minus 1 plus 5 minus 1 square is 1 plus 3 into minus 1 plus 1. So I get minus 2 plus 5 minus 3 plus 1. I get 1. Okay, so this is not the solution of x is equal to minus 1 is not a solution. So how to solve it? So there are various iterative processes available, but let's say when should I stop my iteration? So this is one thing. Let's say I put x is equal to minus 2 and I got the value of 1. Let's say for any value, let's say x is equal to x1, I got my f of x with x1 is equal to, let's say I got 0.1, with x is equal to x2, I got, let's say f of x2 is equal to 0.00001. So the question is, should we consider this as a solution, this or this? We can consider this as our solution based on our stopping criteria. Just give me a minute. Yeah. Yes. So the question is, what should be my stopping criteria in any kind of iterations? So my stopping criteria can be, let's say, I am taking some initial guess of xi. Let's say I am getting, when I am putting my xi in that equation, let's say I am getting f of xi is less than equal to 0.000. I am just taking one random number 1. So this can be one stopping criteria, right? Then another stopping criteria can be, let's say, from iterations, from fifth iteration I got x1 and after that iteration I got x2. So let's say my difference between x2 and x1 is less than some tolerance, let's say 0.0001. So what do we mean? These two numbers are more or less same. So this can be our one solution. This can be our stopping criteria. The another criteria can be, we can take x2 minus x1 divided by x1. With respect to one of the value, we can also do this. And if this matches, then this is our stopping criteria and this is our solution. So when we are doing programming, or when we are writing our own code, we need to provide one stopping criteria. We need to provide stopping criteria to find the uh, to find a solution, or to find a place where one should stop. So yes, so this is about stopping criteria. Now let's move ahead. Okay, yeah. So this is about stopping criteria. So what are the various methods available to solve these kind of non-linear equations? So there is one method. I'm sorry. Just a minute. Yeah, there is one method that is called bisection method. So in bisection method, the word itself means bisection. So two sections we are preparing. Let's say this is my x, comma, y, and let's say this is my cow. Let's say this is my cow. And this, then what is the solution? This point is my solution. So in bisection method, what we do, we have some initial guess of, let's say this is my x1, and this is my, okay, this is not x1. Let's say this is my, this is my x1, and according to x1 this is my solution, and this is my x2, and according to x2 this is my solution. So what is the first criteria of bisection method? This x1 and x2, when we put it, this f of x1 and f of x2 should be of opposite signs. So let's say f of x1 is negative here, right? It's in negative y-axis, and f of x2 is in positive y-axis. So what do we do now? We divide our interval. Let's say I am finding x is equal to x1 plus x2 divided by 2, and I am calling it as x mid. So let's say I'm getting x mid somewhere here. This is just approximation. So let's say I'm just getting my x mid here. So now what should I do? According to this x mid, my f of x is negative, and x2 is positive, and x1 is negative. So we can forget this x1 point, and we can now take our new x mid. We can take our x1 as x mid as x1, and we can again find x mid plus x2 by 2. Let's say I got my solution here, my midpoint here. So what I will do next, I will find my solution between here and here. I will forget this point. Okay, so this is how bisection method works. We can take one example. Let's say x square minus 2x plus 1 equal to 0. We all know that solution of this equation is x is equal to 1. Let's say I'm starting with x is equal to 5 and x is equal to 0. X is equal to 5. My solution is 5 square minus 2 times 5 plus 1 minus 10 plus 1. This is 16. This is a positive number, and x is equal to 0 is also positive number. So we can't take two positive numbers, because let's say I am having this positive number and this wasn't. So we are never going to find midpoint that is 0. So that's why we need to have one negative and one positive. Let's say I'm taking x is equal to minus 1. So minus 1 square minus 2 times minus 1 plus 1. I guess that is also positive. Let's say minus 2. That is also, this will always give you a positive solution. Hmm. Let's say I'm taking x cube. X cube minus 2x plus 1 is equal to 0. Okay. Let's take x cube minus 3x plus 3x square plus 2x plus 1 is equal to 0. Let's say my initial guess is x is equal to 1. So my x1 cube minus 3 1 square plus 2 plus 1 is equal to 1 minus 3 plus 3. So I'm getting a positive number. Correct? Yeah, let's do one thing. Let's take here negative 1. So it will be like this. 1 minus 3 plus 1. So I'm getting one negative number of minus 1. X is equal to 2. I'm getting 1. So what does this mean? My solution is lying between 1 and 2. So what I will do, I will find midpoint. So midpoint x mid is equal to 1.5. And I will find my solution as f of x is equal to f of 1.5. I will find 1.5. Let's say I'm getting a, let's say I'm getting my f of 1.5 is equal to positive number. So what I will do, at 1.5 it's a positive number, and at 1 it's a negative number. So my solution should be between 1.5 and 1. So what I will do, I will take my new x is equal to 1 plus 1.5 by 2, that is 1.25. Like this we proceed, and we get this uh, f of x is equal to 0 as our solution. So this is called bisection method. As you can see, it is more tedious one, because you have to, how many times you are going to calculate this f of x. So let's do one thing. Let's move ahead with another method, that is called method of false position. So what is there in method of false position? Okay, I will not discuss this method in really deep, but I will just show you. Let's say this is my equation, right? So this is x1, this is point x1 and value f of x1. This is point x2 and value f of x2. Now look what I'm doing. I'm joining this line. Okay. So this will be having some angle of theta. So what should I write? Tan theta is equal to this distance, that is f of x2 divided by, let's say this is my x3 solution, x2 minus x3, and that tan theta will be equal to f of x2 minus f of x1 divided by x2 minus x1. And now you can have subject as x3 and you can find your x3, then again x3 to x4 you can proceed like this. So this is also one iterative method. This is called method of false position. So the most widely used method, there is one more method, secant method, but we will not discuss it. But the most widely used method is called Newton-Raphson method, that we are going to use this today. Newton-Raphson method. Okay. So what is that in Newton-Raphson method? So let's say this is my curve, similar curve I am taking. So this is my curve. Let's say this is my curve, and let's say I'm having some initial gas x0. So at x0, my solution will be x0 f of x0. Now what we need to do at this point, we will be drawing one tangent. So let's say this is the tangent. What is tangent? Sorry, my drawing is really bad. Oh, not this. Okay, what is tangent? It just touches at one point. Sorry. Wait. Okay, so what is tangent? Tangent is just touching at one point. So let's say this is my tangent and this is x1, right? Now similarly from this point also I will draw one tangent x2. Now similarly this point x3. So like this we can find our solution. So in this case also, what is tan theta? Let's say in this case, this is my theta, this is a line. So tan theta is, my tan theta is equal to f of x0 divided by x1 minus x0. And we are drawing a tangent. So that is nothing but my derivative. So my next point x1 will be is equal to x0 minus f of x0 divided by f prime of x0. Similarly, my next to second point x2 is x1 minus f of x1 divided by f prime of x1. And when do we stop? These x2, let's say I'm here. So there is no need to draw a tangent from here. So what we can say, when my xi plus 1 minus xi divided by xi, we can take anything. I'm just giving one example, is less than equal to 0.000 for this one. So at this point I will stop and I will say that my x of I plus 1 is my solution. So this is how Newton-Raphson method works. So sorry. So let's just first understand one pseudo code for Newton-Raphson method. So what we need to do, we need to give one, okay, let me write it down here, pseudo code. So in Newton-Raphson's method, what do we need to do? We need to provide value of x0. Let's say I want to do 50 iterations. So that is n, that is nothing but iterations. How many iterations I do need to do? And let's say I am providing one value of epsilon, that is my tolerance. And okay, so let's say from I is equal to 1 to n for all n iterations. Let's say if I'm just giving one example, for 1 to n. Okay, what I will do, I will first calculate x1. So xi plus 1 is equal to x0, or let's say x1 is equal to x0 minus f of x0 divided by f prime of x0. Correct? Now what I will do, I will have a error check. not error check exactly, but our stopping criteria is meeting or not. So let's say if I'm just giving simple x1 minus x0 is less than equal to 0.0001. What I will do, I will stop my code. So I will say my solution. Else, now what is else? My new point is x2, right? So I will start with else I is equal to I plus 1. No, we don't need to write I is equal to I plus 1. That is for while loop. We can just say that my x0 x1 is my new x0. So I will go here. I will again find x. This is my x0 now. So I will be here evaluating this again x1 minus x0, and we will do this until and unless we are finding our solution. So this is about Newton-Raphson method. I hope it is clear to everyone about numerical method of Newton-Raphson. So now I will turn on my video. Just give me a minute. Okay. Now I will turn on my video and we can go for coding part. So let's try to write down one code. Let's try to write down one code for Newton-Raphson method. So for that, I will first open my MATLAB. Yeah, yes. So I have opened my MATLAB. So now what we will do, we'll go to one live script. Let's say I want to find a solution of x square. Let's say I'm writing it in comment. Let's say f is equal to x cube minus 3x square plus 5x plus, I don't know this, the solution of this, plus 1 is equal to 0. I want to find this solution. So what I will do according to Newton-Raphson method, let's try to solve this example using Newton-Raphson method. So what was the method for Newton-Raphson? What was the pseudocode? What I need to give? I need to give the value of x0, initial guess, and iterations, how many times I want to do that. So this was for the for loop, but let's say I want to write it with while loop. So for while loop, what I need to do? I need to give iteration, but it's like my iteration is less than equal to this number. Let's say my iteration is 5 and I am starting with my iterations are total 10, and let's say I'm starting with iteration 0. So I need to give that k is less than equal to my maximum iterations. Like that, we can write our code in terms of Newton-Raphson method. So let's try to write it down using while loop. So what I need to give first, I need to give my initial guess. So let's say my initial guess of x is equal to 2. I don't know the solution. I'm just writing it a random number. X is equal to 2. Let's say my maximum iteration. So I am writing max underscore ITR, that is equal to 50. I'm just going for 50 iterations. So let's say while my maximum maximum iterations are less than, sorry, and we need to provide one number k to start our iteration. So let's say k is equal to 0. So how do I need to write it? While my k is less than equal to my maximum iteration. Till then only we will be running it. Before after that we will not be running. Okay. So let's say my function f is equal to, I am writing this equation x cube minus t into x square, x cube minus 3 into x square plus 5 into x, 5 into x is small number, x is in small letter plus 1. So this is my value of x. And what do I need in Newton-Raphson method? I need derivative f prime. So I will be estimating value of f prime. So I will call it as df. df is equal to what will be df? 3 into x square. Sorry, 3 into x square plus, no, minus 6 into x plus 5. So this is my derivative. So what is my solution? X is equal to x minus f divided by derivative of f. Okay. And I can end this and I can write, I have to increase my iterations. So k is equal to k plus 1. And I can end my value. And I can just use this indentation for better representation only. So where is that option? Smart indents. Okay. So this is how I have just written one small code to find a solution. Let's say I'm running it. So I am getting x is equal to minus 0.1795. Let's say what is the value of f? Let's say I want to find the value of f also. That is showing as 0. So see my f is coming 0 when my x, I'm just not putting any semicolon. So it will be just printing on screen. So x is equal to minus 0.1795. My solution or function f is equal to 0. Let me do one thing. Let's do one thing. I am doing format long G. So is it printing in more? Yeah. So see these numbers have increased. So this is one way of solving. This is one way of solving non-linear equations using Newton-Raphson method. Let's go for one our solution. Let's say I'm not going for 50. Let's say I'm just going 5 iterations. So let's see if I'm getting my f is equal to what I'm getting. I'm getting f is equal to minus 1.22 into 10 is to minus 9. That is nothing but my that I can define it as my tolerance. So I can take this as a solution. I don't need to really go till 50 iterations. Let's say this is my, I'm just doing 2 iterations. In 2 iterations, we won't get it. Yeah, see, in 2 iterations, we won't get it. But let's say D. 3 also, we are not getting it. 4, yeah, we are getting it most probably at 5. 4 also, we are not getting exact. But 5, you can see that it's a best solution. 10 is to minus 9. So that is nothing but 0. And 6, it will be mostly 0. As per my understanding, minus 16 it's going 7. So you can take minus 0.1795 as your solution. See, minus 0.1795 values are not changing at all. So this is all about using Newton-Raphson method to solve nonlinear equations. Let's say I don't want to use a Newton-Raphson method. I want to use some MATLAB inbuilt functions. So let's say one of the function for this purpose is fzero. So I will write fzero in this search option and let's see what we are getting. Oh, there is some error. Wait, f0. Yeah. So f0 is used to give the root of nonlinear equation. So what is the format? X is equal to f0 function comma x0. So function is nothing but my equation. So let's say function is cos and my x0 is 1 comma 2. So it will find solution in between 1 and 2. Let's say this is my f x cube minus 2x minus 5 and I have given x0 is equal to 2. So okay, let's solve it one problem using fzero function. Let's take this same example. I will do it in a command window, CLC. I will write x1. I will write x1 is equal to x1 is equal to, okay, let's do one thing. Let's write for first function. Function is equal to this equation, x cube minus 3x square plus 1. This is my function. And let's say I want to find, so let's see from here, sorry, from here, where did it go? Yeah, from here, we have taken the function at the rate this. Now I need to find a solution. So this value is in terms of x, so I need to write it as at the rate. Sorry, okay, I need to write it like this, at the rate of x, and this is my equation. And let's say I want to use my f0, so x1 is equal to f0 of my function comma initial guess. Let's say I'm giving initial guess as here it was 2, so let's say I'm also here giving as 2, and I'm getting minus 0.1795090. So this is the exact value we are getting. Let's say I'm changing my initial guess from 2 to minus 10. So then also it is converging, but it's not always required that Newton-Raphson method converges. So here 10 also it is getting converged. But let's say here, if I do x is equal to 10, it may or it may not converge. Okay. So see, for 10 in 7 iterations, it's not doing. So let's say I'm going for 50 iterations. It may or it may not give a solution. Yeah, it is giving a solution for x is equal to 10 also. And let's try one for negative 10. So negative 10 also it is giving the solution. But remember one thing, Newton-Raphson method may not converge always. So, okay. So we learned how to use f0 function. So there are other various functions available in MATLAB. So one of that another option is fsolve command. Fsolve. So that is basically used for optimization part. Okay, it's not available here. We can go to online and we can check. But before doing that, uh, okay, so this is all about f0. Okay, so let's do one thing. Let's check about fsolve command. I'm sorry, how do I? Yeah, wait. Control N. Yeah, f0 fsolve command in MATLAB. MATLAB. So if we see here fsolve, I don't know why it was not showing in that directory in their documentation, but here it's showing. So x is equal to the format is x is equal to fsolve function comma x0. It is the same format, correct? But this is more, this you can also use to solve series of commands. So let's say I am using the same for x2. I am giving name as x2 and I am writing it as fsolve. Optimization. Okay, I'm not having optimization toolbox. Just give me a minute. Oh, but it will restart my PC. Restart this MATLAB. Oh, so this will be not saved. Okay, let's take fsolve later. Um, okay. Just a minute. My equation is x cube minus 5x square, 3x square plus 5x plus 1. Okay, so if I need to write it again, I can do it. I just copy this code, so I don't need to write it again. Let me install this. Where did that go? Sorry. Optimization toolbox. So I'm installing it. So fsolve is basically used in optimization problems. Ours is not one optimization problem, but we are finding one minimum solution at x is equal to when f of x is 0. So whenever you are not having some toolboxes that you have not installed while installing MATLAB, I just choose MATLAB basic functions. So I did not get all these options. So there is no need to worry whenever you need it. it will show it like that this toolbox is not available and you can directly install it. Okay, so it is getting installed. Okay, MATLAB will shut down. I don't need to save it. I have just copied that. Okay, it is taking some time. I hope you all are given MATLAB license and you can use it. Okay, it is installing. I guess MATLAB will restart. Yeah. Okay. So let's see how we can use this fsolve command to solve the same problem. So I will go to live script and I will copy that previous code. Wait, what is this? Yeah, it is saying that it is installed, I guess. Yeah, okay. We don't need to worry about it. Okay, so I'm just copying that previous code. I am just running it. Yeah, so this was using my Newton-Raphson. Then let's say this is my function and I want to solve it using first fzero. So this is using fzero. Now let's say I want to use fsolve and I am calling it as x2. Fsolve. So using fsolve, it's taking some time. So see, it is also giving minus 0.1795. But here there are some additional details with fsolve near zero. So what is stopping criteria? So see, stopping criteria, the value is 1.79607 into 10 raised to minus 7. That is sufficiently fair to assume that as zero. So this was one of the way to solve. So see, this x is using Newton-Raphson minus 0.1795, x1 using f0 command, x2 using fsolve command, and there is one more command to solve this equation. So it is called roots. But roots won't be always useful. Roots will be useful for algebraic equations only. It won't be useful for transcendental that I earlier taught. So see, this is my equation 3x square minus 2x minus 4 is equal to 0. So what do I need to do? I just need to write the coefficients. So see, x square is 3, x is minus 2, and x raised to 0 or constant is minus 4, and I just need to use roots command. And let's say it's like this, x raised to 4 minus 1 is equal to 0. So for power 4, it is 1, 3, 0, 2, 0, 1, 0, and constant is minus 1. Like this, we can solve it. So let's say I'm using roots command. So roots, how do I write it? Okay, roots of p. So say roots of, I am writing my function as x cube, coefficient is 1, x square, it is minus 3, x, 5, and 1. I guess it will work like this. Yeah. So see, this is my solution. This one is my imaginary solution. These two, it's a cubic equation, right? So we should get three solutions. So these two are my imaginary solutions, and this last one that is non-imaginary, you can see 0 and this is minus 0.1795. Let me write it as x3 equal to this. So see, okay, it's showing a matrix, but just real number is minus 0.1795. So from all the three ways, we got the exact solution, or better way, we got the same answer using all three methods or all three functions. So this is how we can solve nonlinear. This is how we can solve nonlinear equations. Okay, so let's take one example from your chemical engineering thermodynamics book. Just give me a minute. I need to put my laptop on charge. Okay. Yeah, I guess my screen is also visible and I'm also visible. So let's move ahead with our presentation here. So let's solve this non-linear equation. Sorry, I don't know why it's coming up here. Hmm. Okay, so see, this is my equation. What is equation of state? Equation of state is used to find the roots of vapor liquid coexistence. That is, one root is vapor root and one root is liquid root. So this is my equation of state. P is equal to RT divided by what is the simplest form of equation of state? That is ideal gas. PV is equal to RT. If you put all these constant A, epsilon, sigma, everything to be zero, then you get A epsilon sigma and be all. If you put zero, then you get your original equation of state with ideal gas. PV is equal to RT. Correct. Now, but ideal gas law is not valid in all conditions. It is valid only at low pressure and high temperature, right? Very low pressure, so there won't be any interactions between gases. So after that, in 1873, Van der Waals equation of state was developed. Then RK, SRK, and Peng Robinson. So these are the constants for individual equation of state. Alpha is 1 in case of Van der Waals. There is no epsilon, sigma, only omega and psi. So like this, Van der Waals, RK, SRK, PR, as you go from Van der Waals to PR, you can see that this alpha expression is really complex. And omega is eccentric factor that you need to know for a molecule. So this is how we can use equation of state. And if we write it in terms of this way, if we convert this equation in v cube, v square, v and zero terms, so we get this kind of equation. Okay, so let's try to solve this equation first using Newton-Raphson method, then using fsolve, fzero, and roots command. Okay. So let's do one thing. Uh, okay, so problem statement is this, that this is from your J.M. Smith Introduction to Chemical Engineering Thermodynamics book, chapter 3. And we are told to find vapor pressure of N-butane at 350 Kelvin temperature and 9.4573 bar pressure. So how can we solve this? Okay, so to solve this using, let's say I'm using, here we are told RK equation of state. So what do we need for RK equation of state? We need to know value of PR, only PR, nothing else. So let's write one code. I am giving all values from book only, so you can check it in the appendix of James Smith book. Okay, so value of gas constant 0.08206 I'm writing. Then value of T, let's say, what is the temperature given in our problem statement? Value is given as 350 Kelvin, right? So T is equal to 350 and pressure is, I'm sorry, just a minute. Yeah. Okay. R I'm taking it in different form, 83.14. T is 350 Kelvin. Then pressure is equal to, what is the pressure given? 9.4573. 4573. And critical point of this N-butane and butane. Yeah. So from the James Smith book only, critical point of N-butane is 425.1 Kelvin and critical pressure is equal to 37.96 bar. It is very much required to be consistent in units. Okay. So one thing we need here as input is value of, you can see here, what do we need as input for RK equation of state? We need value of TR. So we need reduced temperature. So TR is defined as T divided by TC. And okay, there is one more input, but that is not required for RK equation of state. I'm just writing omega is equal to 0.2. Okay. So let's say I'm solving it for RK equation of state. So my alpha, what is the value of alpha in RK equation of state? 1 divided by square root of TR, or TR is to minus 1 by 2. So I will just write it down as 1 divided by square root. Square root is written as SQRT of TR. This is my alpha. Okay. What is the value of psi? Value of psi is 0.42748. I will write psi equal to 0.42748. Correct? And what is the value of omega? 0.08664 is the value of omega, and sigma is 1 and epsilon is, we are doing RK, yeah, sigma is 1 and epsilon is 0. So sigma is equal to 1, epsilon is equal to 0. Okay. So now I need to know what is the value of A and B. So this part, let's go to book and see how we can calculate it. Chemical engineering, thermodynamics. Yeah, this is the book. So if we check this book, sorry, not this version. Um, this version, right? Yeah. So this is from chapter 3. Chapter 3, yeah. So let's go to chapter 3. Chapter 3 here. Yeah, this problem 3 point, no, not 3.8, 3.9. Right? This problem. So here my A is this value. Psi alpha by omega TR. No, this is not A, sorry. This is not A. Yeah, here. Yeah, A is psi R square DC square by PC. So I will just write down A is equal to psi into R square into PC square divided by PC. And B is equal to, what is the value of B? R TC by omega into R into TC by PC. So value of B is omega into R into TC divided by PC. This is the value of B. So I have A and B. So now I need to solve this. So, sorry, I need to, yeah, I need to solve this. So what is the value of, what is the value of A? A1 is equal to P. So I will write A1 is equal to P. A2 is equal to, I'm not doing anything new. I'm just copying from here, minus, then a big bracket, R into T. I will write individual terms, R into T plus B into P minus, be really careful, same term, B into P into epsilon plus sigma. So epsilon plus sigma. This bracket is closed. This bracket is closed. This bracket is closed. All brackets are closed. This bracket is closed here. This bracket is closed here and whole negative bracket is closed. Okay, so this is my value of A2. Now my A3 is A minus. So A3 is equal to A minus BRT. This whole term is in multiplication. So be careful while writing B into R into T BRT plus PB square. So I am writing it here as plus T into B into B and whole bracket, right? This term is in bracket. Together, this together is multiplied by epsilon plus sigma. Epsilon plus sigma. Let's put one more bracket here to separate this term. Okay. Then the last term is plus P epsilon sigma B square. Plus, I will write it in bracket, P epsilon sigma into B square. So B into B, or you can write B square directly. This is my A3. In my value of A4 is equal to minus AB. So minus A into B. Okay, everything is in minus, so no need to worry. Minus AB minus epsilon sigma B square RT. So I will just copy this term epsilon sigma B square from here. Okay, for better, it's just put it like this. Epsilon sigma B square, epsilon sigma B square into RT. So into RT, R into T. Okay. Then last term is minus epsilon sigma B cube minus epsilon sigma B square. I'm copying from here and I will just add one multiplication of B. Okay. So what we have done, we have prepared our A1, A2, A3, A4 matrix, and my solution is A1 V cube plus A2 V square plus A3 V plus A4 is equal to 0. Correct? So now, how can I solve this? So let's say I want to solve this equation using Newton-Raphson method. So what I will do, I will do K1 is equal to 0 like earlier we did. K1 is equal to 0. Let me copy from here only. I will have to anyway change it because our equation is different. Okay, let me write it down by my own. Let's say maximum iteration is equal to 50. We don't even need that much. Okay, tolerance is equal to, let's say, 1 into 10 raised to minus 6. So I can write it as 1e minus 6. This means 1 into 10 raised to minus 6. And what should be my initial gas? For my vapor solution, my initial gas would be ideal gas solution, right? R into T divided by P. This is my initial gas. Let's say while K1 is less than or equal to, or just let's say less than maximum iteration, my function f is equal to, what is my cubic equation of state? This A1 V cube A1 into V1 cube, because I have written it as V1. I can just write it as V also, not a big deal. But as I want to use the tolerance term, I have written V1 and V2. V cube plus A2 into V1 square plus A3 into B plus A4. This is my F. Now, what do I need for Newton-Raphson method? I need derivative. So df, what is the derivative of a1 v1 cube? So it will be 3 into a1 into v1 square. Correct? This is my derivative. Plus a2 v1 square, 2a2 v1. Correct? 2 into a2 into v1. Then third term, it is just a3. Correct? Now my solution x2 is equal to x1 minus f of x divided by f prime of x. Okay. Now let's say if, okay, let's say I want to find ABS. What is the value of 5 minus 3? That is 2. What is the value of 3 minus 5? Minus 2. But let's say I just want a positive number. So let's say I am writing absolute of 3 minus 5. So it will give me positive answer 2. So if absolute value of, I'm just taking criteria 2, V2 minus V1 is less than equal to my tolerance. So what I will do, I will break my loop. That will be my solution. Else, what will happen? My value of V2, it will be assigned to V1. Correct? And I need to put one end for this loop. Okay. Then what I need to do? This end loop is over. But I need to increase my K also, right? To go for next iteration. So I will write K1 is equal to K1 plus 1. Or yeah, K1 is equal to K1 plus 1. So that will be my K1. And I will put one and here. And let's do one thing. Let's go for smart indent. Okay. And let's say I'm running this. So let's see what we are getting our solution. Okay, V is unrecognized. Where is V unrecognized? Okay, here it is V1, not V. Okay. V1 we have defined V. I'm sorry, just a minute. I'm sorry. I'm sorry for this. Okay, so let's say what solution we are getting. So I will run it. Okay. So the solution that I am getting is okay. It's not printed because we have not kept anything. Let's say I am keeping V1. So now I should get, or here also from here also we could have checked that. The solution is coming as 2624. So let's check from book what was their answer for this problem. So for RK equation of state, uh, what is the answer? Sorry, 2624. Okay, is that the same temperature and pressure? Yeah, 359, but okay. So this is how we can solve this using RK equation of state. Let's say I don't want to write down this, but one more important thing, it has only given us one root. It has not provided us two roots. Okay. So I can change my initial gas from ideal gas 1 to some other value. Let's say I'm just giving one random value of V1 instead of RT by P. Let's say I'm giving liquid volume is higher. So let's say I'm giving 6,000. Vapor volume is higher, sorry. So what is the value of V I'm getting? 2624 only. Okay, let's see from here what is the second root. Okay, yeah, liquid root is smaller. Sorry, vapor root is already higher we have got. So let's go for smaller root and let's say it's 100. and I am getting it as 152. Okay, so quite reasonable values we have received. Okay, so this is how we can do this using uh, this method, Newton-Raphson method. But let's say I don't want to use Newton-Raphson method. I want to write down direct function. So what I will do, I have already defined my, I have not defined my function, let's say. So I'm defining my function f is equal to, let's say I'm commenting everything here because I don't need these values right now. Comments. Okay. This can be somewhat, you just need to elaborate this expression and check what you are exactly getting. So let's say f is equal to, let's first go with f0. So at the rate v, now I need to write e1. Okay, I'll just copy it from here. I don't want to write it down again. So this term, and I will put my variable as v1. Okay, so this is my equation of f, and let's say my solution v is equal to f0. Then I need to write my function and initial guess, let's say it is some 2000. Let's see what we are getting. We are getting same amount 2624. I want to check one thing, can we get multiple solutions or not? So let's say I'm giving 100 and 4000 just for a try. I'm not sure if it will work or not. Okay, it is giving only one root 2624. Okay. So this is using fzero command. Similar way, nothing different. If I now write fsolve, only the method is different. Fsolve. So I will run it. So okay, it gave liquid root because my initial guess is 100. It gave 152 and it stopped at 1 into 10 raised to minus 3. Okay, so the another method to solve this is roots. So for roots, what do we need? We just need to write coefficients, right? So I will write v is equal to roots of a1, a2, a3, and a4. And let me run this. Okay, so we should get three roots and we are getting three roots. This middle root is called insignificant root. That is not significant. One is vapor root, one is liquid root. If you see this diagram, temperature density curve. This is PV curve. I don't need PV curve. There is VT curve. Okay, they are not shown it. But from VT diagram, there is there. Wait a minute. I want to show that line to you. PT diagram. In PV diagram. No, it's not here. Okay, just give me a minute. I will show it to you in somewhere else, other place. From my notes, I will show you. Okay. Okay, I also have not written it. Okay. But it's like the first root is vapor root, one root is vapor root, one root is liquid root, and the another one is insignificant one. Okay. So this is how you can solve equation of state. So you don't need to write down, if you wish, you can write down your, what do you say? If you wish, you can write down your Newton-Raphson method or any other method code, but there is no need to write it down. You can directly solve this using MATLAB inbuilt functions. So I have one more problem statement ready, but before proceeding ahead with our problem statements, let's do one thing. Let's go to question answers that we will try to solve. This problem we will take later. This one, compressibility charge. Let's go to problem. So the first problem is find the root of the equation f of x is equal to 0 near x is equal to 1.2 using f0 function in MATLAB. And my function is f of x is equal to e raised to x minus 3x. And I want to find it near x is equal to 1.2. So what I will do, I will write my function is equal to, function is in terms of x. So I will write function is equal to at the rate of x, sorry, it's small x. You can even write it capital X, it doesn't matter. E raised to x minus 3x. So e raised to x is written as exponent. So exponent of x minus 3 into x. So this is my function. And I am supposed to solve it near x is equal to 1.2 using f0. So what I will do f0 x is equal to f0 of function near 1.2. Okay, so see, I am getting my solution is 1.512134. Let's see if I would have used fsolve, we are going to get same amount. Okay, but here we will get some stopping criteria in detail. Yeah, see. Okay, we can't use roots command because roots is only used for solving polynomial x cube x square kind of equation. This is not polynomial, this is transcendental equation. So this we can't solve using this roots command. Okay, let's go with another problem. Find the roots of the following equation in the interval 1 to 2 using fsolve command in MATLAB, and my equation is x into e raised to x is equal to 5. Okay, so okay, so my equation is x into e raised to x is equal to 5. So how will I write it down? I will write it down as f of x is equal to x into e raised to x minus 5. Okay, so I will write as function is equal to at the rate of x. Then my equation is x into e raised to x minus 5 is equal to 0. So x into exponent of x minus 5 that is equal to 0. So this is my equation. And I want to find 0 in interval 1 to 2 using fsolve command. So using fsolve command, right? So we will use, let's say x is equal to fsolve. I need to write my function, then my interval. So here it is 1 to 2. So in between 1 to 2, I need to write it like this, 1, 1 and 2 in square bracket. So it will take it as an interval. So see, okay, there is some error. Okay, it is a vector. So I need to put here this dot. Yeah. See, I'm getting one solution only 1.3267. I guess in F0 we can't. Yeah, it's just giving one answer. Okay. So using fsolve, you can get multiple answers together. So this is fsolve command. So I got 1.3267. We can also check what is the value 1 point. What was my function? Function was this. Okay, let me just see x is equal to this value 1 point, or no, we can just directly write it as this. I just need to see what is the value I'm getting. So I'll just do this. Oh no. See, I'm getting exactly 0. Okay. Okay, so let's move ahead with the next problem. For the turbulent flow through pipes, the friction factor is a function of Reynolds number and the relative roughness phi. The Colebrook equation correlation is given by this 1 upon square root of f is equal to minus 0.8686 ln of phi divided by 3.7 plus 2.51 divided by Reynolds number into square root of f. So we are supposed to solve this. Okay. So this one is one complex, I won't say difficult, but it one is a complex relation. So we need to be careful while defining our function. Okay, so let's take this phi value. Phi I will write as Q or capital Q is equal to 2 into 10 raised to 3. So 2e minus 3. 2 into 10 raised to minus 3 is my phi value. And Reynolds number is 5 into 10 raised to 5. So it is in turbulent region, right? Then I need to solve this equation. So I will write function is equal to, at the rate I am writing in terms of f, small f, sorry, okay, I will write down my equation. This one is a complex equation. So I will write it as 1 divided by square root of f. So first term 1 divided by sqrt of f. So this is my first term in first bracket. Plus, let's use second term bracket for second term. So this equation will go this side plus 0.8686, 0.8686 into log. Natural log is given by log only in MATLAB. I guess if you use ln, no, there is nothing called ln. If you need base 10 log, you need to write it like this. But here it is ln. So ln, okay, here also two terms, phi divided by 3.7, okay, plus 2.51 divided by Reynolds number into square root of f. So this bracket is over, this bracket is over, this bracket is over, this ln bracket is over, this second bracket is over, and this whole function bracket is over. We be really careful while defining functions. So this is the function that I have defined. Now I need to find a solution. So let's, what is the initial guess? Initial guess we are not given. So let's say I am taking f is equal to f0 of function, comma, let's say I'm taking my scale 0.00. I don't know what is the answer. Okay, for 0.001, I am not getting the solution. 0. Let's say 1. Okay, we are not getting it. Just a minute, let me check. Let me check the. I will just stop sharing my screen for a minute. Let me check the problem statement once again. It is here. Okay, so okay, I guess we have made some mistake for defining the function as far as I am understanding. Okay, let's check it again because problem statement is clear. Problem statement is correct. So let's check if we have defined it correctly or not. So it is 1 divided by sqrt of f. So this is my whole one term. Yeah, then 0.8686 into logarithm of q divided by, sorry, where did that problem, q divided by 3.7, q divided by 3.7, this bracket is closed, plus 2.51 divided by Reynolds number into sqrt of friction factor. So this is closed, this is closed, this is closed. Yeah, it's correct. I don't know why I'm not getting the answer. Okay, let me try fsolve. Okay, with fsolve we are getting the answer, but with f0 we are not getting the answer. So fsolve is giving us answer is 0.023788. Yeah, okay. So see, f0 did not give us answer, but in this case, by using fsolve, we got the correct value of friction factor for this turbulent flow. Okay, let's move it. The adiabatic flame temperature T in Kelvin for burning methanol with 100% excess air in the furnace is given by the following expression. It's a cubic equation, right? The adiabatic flame temperature is the upper bound of the temperature that is reached by the actual process and serves as an important parameter for furnace design. Find the adiabatic flame temperature in Kelvin correct to two figures using fsolve command. Okay, so let's solve this equation. We'll do clear all. See, okay. So my expression is function is equal to, it's in terms of t, so I'm writing it as at the rate t, okay, 1.3 into 10 is to minus 8, 1.3 into 10 is to minus 8, so it is e minus 8. So this means 1.3 into 10 is to minus 8 into t cube into t is to 3. This is my first term. Then plus, be really careful. This kind of questions will be there in your final exams. So be careful while you are copying the numbers from your problem statement. 4.9 into 10 is to minus 5. 4.9 e minus 5 into t square plus 0.47 into t. 0.47 into t minus 681.7. So this is my equation. What is the issue? Okay, there is some issue with bracket. Okay, there is no bracket here. Okay, this is correct. Now let's say I'm using f0. Let's try to solve it using first f0. T is equal to f0 of my function fun. Let's say I'm giving some initial gas of 300. Oh, so I got my answer is 1238.11. It's a cubic equation, right? So we will have three, we should have three temperatures. Let's say I'm going for a huge, very small number, 1. Then also I'm getting correct. So, okay. So I guess this is our answer, but it's a cubic equation. So we should get three solutions. So what could be those three solutions? So fsolve will also not give us those three solutions, but how can we get it? We can get it using roots command. So I will write, uh, okay, it's a cubic equation. So I will just copy these coefficients from here only. So my roots of, or let's say, a1 is equal to this value, a1, a2 is equal to this 10 is to minus 5, correct? And a3 is equal to 0.47, positive number, and a4 is equal to minus 681.7. Okay, and I want to find the roots. So t is equal to roots of a1, a2, a3, and a4. I have taught this earlier in this lecture. So see, so that's why we were only getting one answer for these multiple assumptions, because our this first and second root were imaginary numbers or imaginary planes. So it was not showing this. Our actual answer is 1238.1137. Okay, so this is how you can also use roots command, but this roots command we can only use for polynomial nonlinear equations, not for transcendental nonlinear equations. Okay, I hope whoever has joined, you are understanding whatever I am teaching. Next point, next question. In a tubular reactor with axial dispersion and closed boundary conditions, the Piclet number of the reactor is related to first and second moments of the residence time distribution in a particular experiment as 2 divided by Piclet square, Piclet numbers square into Piclet number minus 1 plus exponent of minus Piclet number is equal to 0.25. So these I need to solve. Correct. So same thing we can do here also. I will define my function fun. I'm sorry, just give me a minute. Okay, so let's try to solve this problem. So the problem was this one. Okay, so let's solve this using fzero command. So the equation. Hello, someone's mic is on. Okay, let me. Okay, let's solve this using fzero command. So I will write function is equal to. Hello, I will write it down as function is equal to at the rate of. Where is at the rate? At the rate of Piclet number. So I'm writing it as at the rate of PE Piclet number. Then my equation is this one 2 divided by Piclet square. So let's write it like this term first. Piclet number minus 1 plus exponent of minus Piclet number. Okay. This whole term, okay, I need to be careful here while typing. This whole term is multiplied by 2 and divide by Piclet number square. Divide by Piclet number square. So this is my equation and I need to find the solution of this equation. So this is my equation and I will use fsolve command is told to us, I guess, or f0. Let me check it. It is fsolve command. Okay. So my solution Piclet number is equal to fsolve of my function, comma, initial guess. I don't know what can be the answer. So let's just take some random number 2. I have just given set 2. So I got the answer is 193.3125. Okay. So this is my solution. Let's go for some another initial guess 50. We will get the same answer. Uh, I am not sure if we will get with F0. Yeah, with F0 it's not showing the solution. Okay. So okay, so this is the solution of Piclet numbers problem using fsolve command. Okay, let's move ahead in our problem list. So our problem is next problem is how do you create a MATLAB? How do you create a function file in a MATLAB? So whenever I want to uh, create a function, what I write. Wait, let me show you one example of a function file and then let's try to answer this question. So this is my function file, factorial underscore one. So the factorial underscore one, no, this is not function file, I'm sorry. This is my function file. So see, this is my function file. So function file is starting with function is equal to whatever you want to find is equal to function name into your variable. So what is the extension of function file? It is .m and it is starting with function. So our answer should be begin m file with function definition. So this m file is starting with the function definition. Whenever it is starting with function definition, this is called function file. And one more important thing to remember, let's say you are saving this, you are writing here function find underscore factorial. So this name also should be default to find underscore factorial. This can't be different. So our answer is this begin m file with function definition. Next question, what is the default increment value of a for loop? Let's say I am writing one small code just to explain you. Let's say I am saying for I is equal to 1 colon 3 I end. I just want to print end. I just want to print end I. So let's see what I'm getting 1, 2, and 3. So what is the default value of I loop? It is 1. Let's say I'm going till 10. So it will be showing me till 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But let's say I don't want to go in interval of 1. I want to go it in interval of 3. So I need to put one between 1 and 10. I need to put one 3 colon 10. So this will give it as 1, 4, 7, 10. So whenever we are not writing anything, it will automatically taking it as 1. So what should be our answer? The default increment value for a for loop is 1. So answer should be answer B. Okay, next question. Variables need to have same name while being passed from the primary function to the subject function. Okay, let's take that factorial example again and let's try to understand. Okay, this is my function find underscore factorial. Let's say I'm calling my find underscore factorial of, let's say I'm writing m is equal to 10 and I'm calling my factorial function to find a value. It's not the live script, right? Okay, I need a live script. Okay, I guess I can write it here. M is equal to 10. And let's say I want to find factorial using this find underscore factorial of m. It has not, yeah, it has recognized now. So see here, what is the name of the variable? It is n here in my definition. But here, when I want to execute it, I have written it m. So what it does, it take m as n and it does this calculation. So it's not required that, let's say if you are taking here n, I should also take here m. I can take any variable. So the answer is false, but it is, this is really a very small code, so it won't matter here. But if you are dealing with a long, very large system, so it is always advisable to take the same names so it won't create any kind of unnecessary confusions. Okay. Okay, so next question. What is the output of the following code? I is equal to 0, then there is one semicolon. So it won't print I is equal to 0, but it will start with I is equal to 0. For I is equal to 0 colon 2. So from when value of I is in between, first it is 0, then it is 1. So see here it is I 0, then it will take I is equal to, sorry, 1. Then again it will go I is equal to 1. It is 1, I equal to 2, value is 1. But here everywhere we can see that there is one semicolon. Sorry, here it won't matter because it is in loop, so this won't be printed. But here it's not a semicolon. Here it's a semicolon, here it's a semicolon. So we won't get any output printed on the screen. So our answer should be output is suppressed. So see, we can even do this here to check when we are writing it in. Let's say I have written I is equal to 0 for I is equal to 0 colon 2, 2, I is equal to 1 and end. Okay, and I am running it. So see, I'm not getting, wait, let me do this clear all CLC. Okay, now let's run it. So see, I'm not getting anything printed here. But let's say I'm removing this one. So I will be getting printed 1 3 times. But as there is one semicolon, our output is suppressed. So what is the answer of this question? Output is suppressed. Answer A. So let's go to next question. How would you plot multiple graphs in MATLAB? Okay, let's say I want to plot, I'm taking x is equal to x is equal to 0 colon 0.01 colon 1. So from 0 to 1, it will go in interval of 0.01. Let's say I am finding y1 is equal to exponent of x and y2 is equal to exponent of minus x. Okay. So now I want to plot this. So I will write plot x comma y1 and plot x comma y2. Okay. And let's say I'm running it. So what I am getting, let's see. So see, okay, here it is giving two graphs simultaneously, but when you are dealing with actual script, it will not show two graphs. So for that, yeah, these two are different graphs, but let's say I want to put this both the graphs in same graph. So I will use hold on command. So let's say what is the use of hold on. So let's say when it is hold on. So see on one graph, both the functions e raised to x and e raised to minus x is getting plotted. So my answer should be using hold function. So using hold function, let's say I'm going for multiple more graphs now. I just don't want to go with this. So let's say my y3 is equal to exponent of, let's say it is exponent of minus x square. Okay, it will decay even faster. We'll copy this. Yes. Yeah, okay. X is a, this part is a matrix, right? It's a vector. So I need to put dot when we are dealing with this x square is a scalar operation, but x is a vector. That's why we need to put one dot. So see, this is how it's decaying. But let's say I want to differentiate these things. So let's say I'm putting x label. What is my x label? Let's say it's just x. Y label, let's just put it as y. But I want to differentiate these colors. So how can I differentiate these colors? Using label. So my first plot is y1, then my second plot is y2, and then my third plot is y3. Okay, let's say I'm running it. Label, not label, sorry, legend. Sorry, legend. Yeah. So see here y1, y2, and y3. You can also give colors as your convenience. Let's say I want to give black to this. So for black, it's code K. For blue, it's minus B. Sorry, not here. Here, when we are plotting it. Let's say I want to give it as black. I'll just write K. Let's say I want here blue color. So I write B. And let's say I want here green. Let's run it now. So see, it is as per our convenience. Okay, so this is how we can plot it, and the question was how we can plot multiple plots. So the answer is using holder function. I hope whoever has joined, you're getting, you're understanding. Now, next question. What is the final value of j from the following code? J is equal to 0 colon 3. So what does 0 colon 3 means? It will start with 0, then 1, then 2, then 3. So when it is j is equal to, when it is, sorry, I'm not able to write here. Wait, yeah. Here, let's say first j is equal to 0 colon 3, meaning j is 0, 1, 2, 3. Now, first it will take j is equal to 0. My output j for from the first loop, it is 1. Then my j is 1. My next is 2. Here it is 2. Now, here it's 2. Here it is now for value of 2, it is 3. For value of 3, it is 4. So my final value from j should be 4. Correct? Let's check it in MATLAB also. It's not really difficult to do. Okay. So 4, let's write it down here. Or let's take one new line script. 4. Let me do clear all. CLC. 4. J is equal to 0 colon 3. J is equal to J plus 1. And okay. So what I'm getting, I'm not getting any answer, but my final value of J is 4. But let's say I'm getting J from minus 2 to 1. Then also I will get my value of, then I will get my value of J as 2, because when it is minus 2, my answer will be minus 1. Then when it is minus 1, my answer will be 0. When it is 0, my answer will be 1. And when my answer here is 1, answer will be 2. So this is how we can do this. Now, next question. If nested loops, in the nested loops, if break statement exists only from loops in which it occurs. The break statement exists only from the loop in which occurs. So this is a true statement. We have already taken the example of that while loop. I will show it to you again. I have saved that code. So no, that is not nested if loop actually. Uh, this one is not one nested if. No, this one is not one nested if loop. Okay, for nested if loop, we have taken this factorial code. It has nested if loop. Yeah, see. So if this statement is broken, only this part, how do I explain it better? Um, Let me take some nested if meaning. Let's try to write it down by our own. Let's say x is equal to 0. Let's say I'm writing if x is greater than 1, if x is less than 1, I if if x is equal to 0, I else break. Okay, this is my one loop and and. But before that, let's say I am seeing it as here the break is here. But let's say I am writing something here for, let's say I is equal to, not I. Let's say here I am giving one more statement if uh, x is less than 0. Okay, so what will happen? Okay, equal to, sorry, here it's equal to. Okay, there is no break here. While here, let's write while. Okay, let's try to run here break. So what will happen when we are writing break here? It will only break this if loop, this part. It won't break this whole while loop. This is what it is trying to say. This is what the question is trying to ask. Okay, so it will just exit that particular loop. Break is here, so it will break this if loop. It won't break this while loop. Or let's say if here there is one if loop, so it won't break this whole while loop or whole if loop. This is what it is the question is trying to ask. Okay, so let's go with the next problem. Okay. While running a loop in MATLAB, it does not require indentation. Yeah, it does not require it, right? Let's say I'm writing something in C here. It's not, let's say I'm writing it like this. So it's not indented, right? But still it's running, right? I'm running it and it's running. So it's not required. But why it is required? It is required to it is required to have a good practice to understand your code. See if this if and loop is ending here, this while loop is ending here, this if loop is ending here. It is just for better understanding. So it is not required, but it is practiced or it is advised to always write it in that term. Okay. In laminar flow, the roughness of pipe has no effect on the friction factor. Is this true? Darcy's friction factor F is defined as, in laminar flow, F is defined as 64 by RE. So it is independent of roughness. Reynolds number is nothing but rho d by mu. Okay, so it is independent of roughness factor. So my answer should be true, right? Next problem. Head loss due to the friction in circular pipe of constant diameter d under laminar flow conditions is inversely proportional to. So how head loss is given? So I have written the equation. So that is given by 32 mu velocity delta L divided by rho g d square. Now by seeing this equation, anyone can say that my answer should be d square. But it can't be d square because velocity is already having diameter term, right? So what is velocity? Velocity is defined by Q volumetric flow rate divided by area. That is area. Let's say it's a circular pipe. It is told in the question. So it is pi by 4 d square. So it should be Q divided by here pi by 4 d square. So it is dependent on d square into d square, that is 1 upon d raised to 4. So my answer should be this. It is inversely proportional to d raised to 4. Okay. And this is just for laminar flow, right? It's not for turbulent flow. Okay. Let's move ahead. The Fanning's friction factor in the pipe of constant diameter in which viscous flow is taking place in is given in terms of Reynolds number S. So friction factor is given. It's a solid. It is asked in Fanning friction factor. So F is nothing but 16 by RE. And when we are taking Darcy's friction factor, F is nothing but 4 into Fanning friction factor, that is 4 into 64, that is 64 by RE. When we are looking at that friction factor versus Reynolds number chart, in that chart the friction factor is nothing but Darcy's friction factor. Where did it go? Yeah, it is Darcy's friction factor. But here it is asked in terms of Fanning friction factor. So our answer should be 16 divided by Reynolds number. Okay. Just give me a minute. Okay. Next question. Friction loss in non-circular conduits can be employed using the same set of equations used for circular pipes. If the diameter, if we need to take uh, diameter, we are asked about diameter, we are not asked about radius. So diameter is taken as, this is theoretical question, it is taken as 4 into hydraulic radius for non-circular pipes. So hydraulic radius, sorry, I'm sorry. Hydraulic radius is given as nothing but flow area divided by wetted perimeter. Okay, so this is how we can find hydraulic radius. So the answer should be this 4 into hydraulic radius when we are dealing with non-circular conduits. Okay. Now next question. Okay, find the zeros of the nonlinear equation near x is equal to -1 using f0 command. Our equation is x cube minus x sine x plus 1 is equal to 0. So let's solve it. Okay, we have 15 minutes left. So let's try to complete our assignment, these problems. So my problem statement is x cube minus x into sine x plus 1. So f function, I don't need this actually. I don't even need this. Function is equal to at the rate of x. Okay. My function is x cube minus x into sine x plus 1. So I will write x cube minus x into sine of x plus 1. This is my function. And let's say my solution is x is equal to function f0 of function comma. Okay. What is the at near x is equal to minus 1? So I'm just writing minus 1. So, okay, so my answer that I'm getting is minus 0.774. So here we can see sine 90 is 0.89. But let's say I'm writing it as sine pi. So it is coming as 1. So this value is in radian. This 90 is in radian. You can convert pi by 2 into 360 by 180 by pi. So we are getting 90. So see, the answer that you are getting is in radians. Okay. So when it's 0.89399, this number, we are getting the zero of this particular equation, x cube minus x into sine x plus 1. Can we write one small code? Newton-Raphson x cube minus x into sine x plus 1 equal to 0. Let's say my initial guess x is equal to minus 1, we are told, correct? E is equal to 0. Maximum iteration, or let's not go with that maximum iteration part. Let's do it simply. While k is less than my max iteration, let's say I'm going with 10. My function f is equal to this x cube minus x into sine x plus 1. Here I guess I need to put one bracket as it will show it as an error, right? Okay, so what is the differential of this function? X cube 3 into x square x into x minus what is the differential of x into sine x? Let's say first x is constant, sine x, it's cos x, and second time sine x is constant and differential of x is 1 and differential of 1 is 0. Okay, so my solution is x is equal to x minus f by df. K is equal to k plus 1. I need to increase the value of k by 1. And let's see what we are getting. So see, here also we are getting minus 0.77245283. See, it's the similar solution only. Okay, so this is how we can also solve these problems, same problem using Newton-Raphson method. Okay, let's move ahead with the next question. Just give me a minute. I need to. Let's try to solve that same problem using fsolve command. This problem. Let's say I'm doing fsolve. Function is this. I'm doing fsolve. So fsolve will also give you the answer. But we can't use roots command because it's not a polynomial equation. Okay. I'm doing clear all CLC for the next question. Okay. 2 raised to x. Sorry. 2 raised to x minus 4 raised to x divided by 3 is equal to 2 by 3. Find a solution of this. So let's first do this using Newton-Raphson method. So my solution is, my question is 2 raised to x minus 4 raised to x, 4 raised to x divided by 3, or let me write it down like this, 4 raised to x divided by 3 plus minus 2 by 3, minus 2 divided by 3. And what will be the differential of this? A raised to x, uh, the differential is a raised to x, a raised to x into log a. So that is not, that is log base 10a, that is not log natural log, right? Okay. So similarly, 4 raised to x, same term, this way, and it is whole answer is divided by 3. So let me put it divided by 3. And 2 raised to 2 by 3, answer is 0. And we are supposed to find a solution at x is equal to 1.5. Let's see what we are getting. We are getting 1.440. Or, okay, we will have to increase our iteration. Let's say it's 100. Okay, it is 1.440 only from what we are getting. So let's try it with fzero command. So I will just copy this function from here. At the rate of x in this equation, and I will write f0 x is equal to f0 x1. Let me write x1. So it won't overwrite this x, this value, x0 of function. You're supposed to find it 1 by. I can't see the answer. Okay, it's not printing anything. So maybe that's why we are solved fsolve. We are okay. The answer is 1, but answer can't be 1, right? 2 minus 4 by 3. Yeah, answer can be 1. 2 minus 4 by 3. So 2 minus 4 by 3 is 6 minus 2 by 3 by 2 by 3, 1. Yeah. Okay, let's solve it using the fsolve command. So it is also showing near to 1. Okay, here I don't know why it's not showing. E raised to x, e raised to x into log a. Hmm. Maybe it requires more and more. I just want to try it. Or maybe for this initial guess of 1.5, it's not working. Let's say I'm going with 0. Newton-Raphson method always, it does not always converges. So C4x is equal to 0. I got my exact answer as 1. Minus 1.1. No. What is the value of that we got? Is minus 1.1 into 10 raised to minus 5. Yeah. So it is not always required the Newton-Raphson method will converge to a solution. Okay. Our next problem, same problem, f of x is equal to e raised to minus x. Sine of 2x minus 0.5 is equal to 0.25. So let's write down this equation. X e raised to minus x. So exponent of minus x. You need to be really careful. Exponent of minus x into sine of 2 into x minus 0.5. This whole term is subtracted by minus 0.25. This is my function. And or this is my equation. And what I'm supposed to do, I'm supposed to find a solution using f0 in 0 to 1. So let's say x is equal to f0 function comma 0 to 1. So I'm getting 0.4518 is my solution. I guess we will get, not I guess, we will obviously get same answer using solve command. Fsolve is not initiating. I don't know why. Yeah, okay, it's a matrix. Yeah. So we need to write it down in terms of matrix. When we are dealing with matrix, we need to put this dot sign here, 2 dot x. I guess it will work now with fsolve. We didn't work either. Yeah, here also. Here also we must have this dot sign. Wait. Yeah, it should be here. Now it should work. See, it is giving us two solutions using fsolve command 0.4518 and 1.2709. So this is how we can use it. Okay, next question. Find a zero of the function cos x near x is equal to 4. Okay, let's do it using this thing. F of x is my cos x, right? Cos of x. And what is the derivative of cos x? It is minus sin x. Minus sin of x. And what is the initial guess? 4. Let's see what we are getting. Let's just keep 10 intervals. 10. Wait. So I'm getting something 4.7124. I don't want to print x actually. I want to print df. df we are getting f. See, f we are getting is minus 1 into 10 is to minus 16. That is nothing but 0 only. Okay. So we are getting 4.7124. Let's do this using some function. Some f0 command. What is stored? f0 or f0. Anything we can do. f0. At the rate of x, cosine of x, and x is equal to f0 of function, comma, initial guess 4. We'll get the same answer. Nothing to surprise. 4.712388. That is exactly 4.7124. So this is how we can do this. Okay, this question number 22. Let's leave it for now. Okay, so this is all for today's session from my side. So today what we actually learned, we learned first how to solve what are the various kinds of equations like linear equations, non-linear equations, non-linear equations. Someone has question? I can't see anything. Okay, it's something visible. Yes, with the semicolon, your answer gets hidden. Sayan, am I pronouncing your name correctly? It's good to know you are from IIT Kharagpur. I was also, my MTech was also from IIT Kharagpur, and I learned this course from Professor Parag Deshpande only during my MTech. It's good to know. Okay, so in today's session, what we learned non-linear types of equation, linear, non-linear, non-linear equations of two type, algebraic equations and transcendental equations. And to solve this kind of equation, we have just checked first theory part, that is bisection method, false position method, then Newton-Raphson method. Then we took one small algebraic equation to solve it using Newton-Raphson method, and we understood how we can write a code for Newton-Raphson method. Okay, then we took one chemical engineering problem of what can we say, cubic equation of state using RK equation of state. We solve that equation of volume using Newton-Raphson method, and we use three MATLAB inbuilt functions: fzero, fsolve, and roots. Roots can only be used when we are having polynomial kind of equation: a cube, a into v square plus b into v plus c is equal to 0 kind of equation, not for transcendental equation like a into sine x plus b into v square is equal to b into x square is equal to 0. Those kind of equation can't be solved using um, roots command. So we took that chemical engineering problem and we solved using these three functions and absol command. And then we took some previous year assignment problems and we learned how we can use these absol, f0 commands. Okay, so this is all from my side. Thank you everyone. And if you are having any queries, you can write me an email here to this email ID and I will try to respond you ASAP. Okay. So thank you so much, everyone. If you have anything to share or anything to ask, you can turn on your mic and or you can write something in your chat box if you want to ask something. Okay, I guess there is nothing to ask. So we can meet next week. San, are you in second year? Second semester, sorry, not second year. If you can respond, wait, I will stop the recording so it won't go.